for these questions, we can imagine that first there's this plane P1 and the point ABC, the 3 points ABC, they on the plane, and we can imagine also there is another point called P right here, and the coordinates of P is X, Y, and Z. Now, to find the equation of plane P1, we need to know the normal to the plane P1. Any normal would do. The normal is a vector, let's call it N, and it is perpendicular to the plane. One fast way to get the normal to plane P1 would be first by calculating the vector AB and then the vector AC. So if you calculate properly, you should get AB as follow and AC as follow. Now the point is we want to find this normal by finding the cross product of these two vectors. So the aim is to do the cross product AB and AC, and that will be of course your vector N. If you perform this, you should get -45 and 60, 90. We could just use this vector, but you can see that this is really, these are all large numbers. If you proceed, you tend to have really difficult calculations. Since we only want a normal, we can actually just work with things like this. We factor the 15, as we can see, and we end up with -3, 4, and 6. So working with this vector -3, 4, and 6 is similar to working with these vectors with larger components of larger numbers, because they're both normal to the plane P. They're normal like this vector N. So now the idea is to form the vector AP, and the vector AP is, of course, if you dot to the vector N, they are perpendicular, so the resultant will be 0. A vector AP, of course, is actually X -4, and then a Y -5, and Z +3. And you dot it with -3, 4, 6. See, we are only taking this vector, 3, 4, 6, and just ignore the 15. Doesn't really matter. This is 0. If you continue with the calculations, and then what you do is rearrange them so that the constant will be on the right hand side. You end up with -3x plus 4y plus 6z equals to -10. And then they ask us to find equation of straight line, which is perpendicular to the plane, and it goes through the point B. Now let me grab this up so I can write right here. 15, give myself more space. 6. And since they say that the straight line is actually perpendicular to P1, in other words, the line is actually parallel to the normal, isn't it? Right? And so you can say that the line is parallel to the normal. We'll just take -3, 4, 6. You don't need the 15 because it will be the same. So this is, you can take this as a direction vector of the straight line. And so everything here becomes fairly simple now, because the point that we know that to get equation of straight line, we need a point on the line and the direction vector. So we can form this. The parametric form will be x equals to 0 plus -3t. We can simplify that. That's what we have. We end up having -3t. As for y is 2 plus 4t. If you recall that, you take this coordinate and times 4t. And similarly, the z would be, you probably know by now, is -3 plus 60. And of course, t is a parameter.